Hey guys, we are going to start on our weak acid being titrated with a strong base titration curve. In this first video, I'm just going to walk you through the segments of the titration curve, and then in the next video, I'll actually go through the calculation. So this is just to give you an outline of what we're going to be doing in the next video. So we're going to start at the kind of initial point on our titration curve. So in order to get the initial pH, because we are starting with a weak acid, for acetic acid, the initial pH is just simply going to be a weak acid pH calculation. Okay, so we want to be using an ice table, calculating the amount of hydronium in order to find the pH. Now, what you're going to see as we titrate a weak acid with a strong base is we experience this buffer region. So first off, here's our equivalence point. Okay, there's a segment within and around the half equivalence point. So this point right here, I'm going to kind of be pulling this over to the side, is our half equivalence point. So it's halfway to the equivalence point. Okay, at this point, the pH, and this is really important, is equal to the pKa of the weak acid. And why that is that the concentration of the weak acid at that point is going to be equal to the concentration of its conjugate base. Okay, and because those are equal to each other, that then causes the pH to actually be equal to the pKa of it. Now, about in that buffering region, so plus or minus 1 pH above and below, anything in that region, put a box around it, in that region of the amount of sodium hydroxide added is going to be a buffer calculation. Okay, because as the NaOH is added, it's reacting with the weak acid, which is producing the weak acid's conjugate base. So anything in this region, we're going to be using the Henderson-Hasselbalch equation to complete our pH calculations. So you'll see us anytime we're between kind of that initial pH and our equivalence point, we'll be using the Henderson-Hasselbalch equation. So it's just simply a buffer calculation. But again, one really important point is knowing that halfway to the equivalence point, the pH is equal to the pKa. I also think it's useful to have an idea of what's going on before the half equivalence point, and then what's going on in regards to the concentrations between the half equivalence point and the equivalence point. This gets at our buffer discussion earlier this week. So in this little segment here, our pH is less than our pKa. Okay? And if you go back to our notes or video from earlier, what that tells us is that the weak acid concentration should be greater than our conjugate base, which makes sense. We're adding in sodium hydroxide. It's reacting with some of the weak acid to produce its conjugate, but we haven't got to that half equivalence point. So I would expect there to be more of the weak acid versus its conjugate. When you get past the halfway points where the conjugate weak acid and its conjugate base are equal to each other, at that point, our pH is now greater than our pKa, which then means that our weak acid concentration actually less than the conjugate base. Okay, so anywhere after that half equivalence point, as I continue to add in more sodium hydroxide, I'm using up more of the weak acid, producing more of the conjugate, and now the conjugate is in the greater concentration than the weak acid. So that can be helpful with questions that have to do with explaining or looking at the relationship between the weak acid and its conjugate base. Okay, or looking at a diagram somewhere along that curve. Okay, when we get to the half equivalence point, or sorry, not the half, the actual equivalence point, which is already written there. For some reason, I'm going to write it again. One thing to note is when we had a strong acid with a strong base, the pH was equal to 7. Here, the pH, okay, we have a strong base okay, a weak acid, that is going to form a basic salt. So for this, the pH has to be greater than 7 due to that. So we are going to have in this, when we do our calculation, the hydrolysis of a basic salt. So we would have our conjugate reacting with the water to produce the weak acid and hydroxide. Okay, so we'll have, again, we did that in the last unit, and it's going to come right back up here. Anywhere after the equivalence point, this is where we're going to simply be doing, figuring out how much excess hydroxide there is, and then using that to, this would be strong base. So we're basically figuring out how much is our excess strong base, and that concentration of hydroxide will give us our pH value. So you can see with these calculations, we're putting everything together that we've been doing the last couple of weeks. We have our weak acid calculation at the start. We have our buffer calculations between kind of our initial pH and our equivalence point approximately. We have our hydrolysis of a salt at our equivalence point, and then we have excess strong base calculation. Okay, so we're going to be walking through these calculations, but I just want you to have an overview and kind of a summary of what we're going to be doing in the next video to start.